I hope all of you enjoyed your New Year. So I think we have sufficient number. We can start, or we shall wait for some more time. I think we can start, right? So today, actually, by mistake, your Buljit sir took the first class. He thought this to be day 3, so today is day 4. So that kind of confusion happened, and he took the first class. That's why I'm taking during his time. Okay. So today that means we are following day 4. Now onwards, that means it is going to be kind of day 4 only. Okay, understood? Am I audible? Hello. Okay. 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 Thank you. So, do you remember what we discussed in the last class? Do you recall? So, in the last class, basically, actually, we're in this particular module where we are discussing about velocity and acceleration analysis. So, there we have gone through velocity analysis of different mechanisms like the slider crane mechanism, the four-bar mechanism, the separ mechanism, etc. Okay, and we have actually utilized the relative velocity method for doing so. And all those methods, okay, that we already know, that means these are kind of graphical method that we have discussed, and proper scale, doing using the proper scale, using the geometric instruments, doing all those things properly, etc. is very important there. Okay, and there we have got the concept of relative velocity, absolute velocity, etc. And how we draw the velocity diagram, those things also we have discussed. Okay, and we know how to denote the relative velocity of a point with respect to another, or how to designate the absolute velocity, etc. Okay, and whenever with respect to fixed point we are designating, we are talking something with respect to fixed point. Okay, so then it becomes the absolute velocity. Whenever we are talking with respect to one another, then this becomes relative velocity, etc. So those things already we have covered. So today, so up to that much, do you have any doubt? So I believe all of you have understood. Let me know, some of you. If you just let me know whether you have understood the previous things, it will be easy for me to move ahead. Okay, no answer said yes. Okay. So others also, I hope you have understood. So today we are going to discuss about another method of doing this particular analysis, and that is the instantaneous center method. Okay, so relative velocity method we have covered. So instantaneous center method we are going to discuss today. So prior to discussing about the instantaneous center method, we should know about the instantaneous center of rotation. What is instantaneous center of rotation, and why, how it can be, this concept can be utilized to do the velocity analysis of mechanism. Okay, so now if we are talking about the instantaneous center method, I believe this figure is visible to everyone. Okay, so here what we are showing, actually we are showing this link AB, this one. Okay, and okay, so this link we are showing initial position of this link AB. Okay, this one, and we are showing the with A dash A1 and B1 is the final position of this particular motion. Okay, so now if we let's consider a rigid link AB which is moving from this initial position AB to this final position A1 B1, and you can see from this particular figure, apart from this particular displacement, okay, this linear displacement, it has also rotated some. So now this particular movement, okay, that means this AB has reached to A1 B1, so this can be considered as a combination of translation motion. Okay, that means from here this from this to this. Okay, and after that we can consider as if this much rotation also it has got. So translation as well as rotation it is there. Okay, and if we combine them, that means we are going to get the final, this particular, whatever is this particular position. Okay, so that is how we can consider. So that means from from here to here, that means this is the, you can consider as if initial translation motion that is it has got, and after that this much is the rotation that it has got. Okay, so now it is a, can say this A1 B1 is nothing but a kind of combined effect of this translation as well as rotation. Now in that particular case we can consider a particular like we can join this particular A to A1, okay, this one, and B to this B1, that is the initial position of this particular point with the final position of this particular point, and initial position of point B to final position of B, that is B1. Okay, and we can draw the perpendicular bisectors for this AA1 and BB1, and they will intersect. If we draw this perpendicular bisector for AA1, this is this, and if we draw the perpendicular bisector for BB1, this is this, and if you see, then actually it is intersecting at certain point, and that point we are designated with point I. Okay, and it can be assumed that the rotary motion, okay, so for this particular A1, okay, it has considered, it has taken about this particular point, and similarly there will be a point for BB1, okay, suppose this is the L, and ultimately we can consider at the end as if during the whole course of this movement, okay, as if about this particular point, okay, that is the instantaneous center that later on we'll be referring as, okay, as if it is rotating, the whole motion is happening about this particular motion, okay. So this point will not get physically, but there will be a point, okay, about which we can consider as if the whole motion has taken place, and that is nothing but the instantaneous center. And this instantaneous center also sometimes known as the Herschel center also, okay. And as we have seen that the name itself is instantaneous, that is from instant to instant, that word is there, okay. So there will be different instantaneous center for different positions of this particular, okay. So that is this particular thing. And if you draw the instantaneous center, different instantaneous center for different okay, different instances, okay, we'll get different instantaneous center. And if you draw a curve through all the instantaneous center, then you can get a particular locus. That locus is known as the space center. So now here about this we are going to use that concept of this instantaneous center method for determining the velocity. We should know how this instantaneous center actually, about which we can consider as if the whole motion has taken place, how it can be correlated, okay. That means if we know about the instantaneous center of a particular, for a particular suppose link pair and all, okay, then if we know about suppose how it is related with the velocity of that particular link, okay, and that particular concept, if it is known, then we will be able to find out the velocity. That is what is the use of this instantaneous center method. And the application of this knowledge of this instantaneous center, its relationship with the velocity and all, okay. And does if we whatever the method that we use for determining the velocity and all, okay, of this particular mechanism, that is known as the instantaneous center method of velocity analysis. Okay, up to this much I believe it should be okay. Okay, now how this instantaneous center and the velocity, they are related. So now the value of the velocities of a particular point on a link, okay, on a rigid link, it is actually directly proportional to the distance from the instantaneous center. That means if you know about, suppose this is a particular link, you do already know about that link, you know, suppose from within that particular link at which point you are interested in, and if you know suppose about that instantaneous center for that particular position, so in that particular case you can have that particular distance of different points from that instantaneous center. So now actually this velocity of a point on a rigid link, it's actually directly proportional to its distance from the instantaneous center, and that is what is the concept that we are going to utilize in determining the or drawing the velocity diagrams for this particular by this particular method. Okay, and now this is about the like magnitude, okay. That means it is directly proportional to the distance from the instantaneous center, and the direction of the velocity, it is perpendicular to the line joining them with the instantaneous center. Okay, that means if you look with this particular figure, how we can locate the instantaneous center. So actually if suppose this is a link, okay, we have got the link here, that I is the instantaneous center. So now you can see the velocity. See, if you consider this point A, point B, point C on this particular rigid link, and I is the instantaneous center. Okay, and we have got the different. So we want to know about suppose the velocity of point A, B, C. Okay, so actually, okay, so in that particular case, actually, see the velocity of A and velocity of B, velocity of C. What we know, so A point is which particular point is farthest from instantaneous center? Definitely the C. A is the one which is at the shortest distance, and C point is the farthest. Okay, similarly intermediate distance B. Okay, so we know that from this in this particular case. Okay, so velocity is directly proportional from, to the distance, right? So from the instantaneous center, if we consider IA this particular distance, and if you consider suppose IC this particular distance, okay, from this particular figure, which distance is more, IA or IC? This is C, this is A. Which distance is more? Definitely IC. Okay, so velocity of C will be more. Okay, that means this velocity VC, that is for C point, velocity of point C, and velocity of point A. If you look at, okay, from this diagram also you'll be able to understand. Okay, this magnitude is more compared to this. Okay, and how we can correlate them? If VA, VB, and VC are the velocity of this point A, B, and C, okay, and these are the distance IA, IB, IC, then we can write VA by IA, that means velocity of point A, and this distance is will be in the proportional to VB by IB equal to VC by IC. And this concept we can use if we know about the instantaneous center. We can locate the instantaneous center. You should be able to locate the instantaneous center, then the distance as per the scale we'll be able to get, and after that what we can get that particular velocity value, and this is the direction is perpendicular to it. Okay, perpendicular to the link, we already know. Okay, so similar is the case we are showing here how we are locating it. Okay, so actually definitely using this particular value we are getting that particular whatever is the VA value, VB value, or VC value, and direction. Okay, it's a perpendicular, and after that we can just you can complete this particular triangle also, no problem. Okay, up to this pass I believe it's understood how we can use the concept of instantaneous center for determining the velocity. The main concept is we should be able to locate the instantaneous center. Okay, and how to locate the instantaneous center, okay, those things we are going to discuss. We have got different like the relationship. Okay, Kennedy's theorem is there, we can make use of it. Okay, apart from that there are different other known knowledge that we'll be utilizing for finding out the instantaneous center or for locating the instantaneous center. And once the instantaneous center has been located, what you can do, you can as it is, it will be graphical method, so the scale will be already there, and you can find out the distances, and we know the velocity. Okay, it is proportional to the distance from the instantaneous center. Okay, velocity of that particular point. Up to this pass I believe it should be okay. Yes, let me know someone. Hello. Okay, thank you. So now we know that how instantaneous center is related with the velocity. Now we should be able to know also, that means how many instantaneous centers are there for a particular mechanism. Then only we should be able to find out, or there will be the concept of suppose locating the instantaneous center. But prior to that we should know how many are there. Okay, then only we'll be able to locate them properly. So now how to find out the number of instantaneous centers for a particular mechanism. So this number of instantaneous center, which is denoted by capital N, okay, it how we can get, so actually it is related with respect to, there is a relationship, and it is related with respect to the number of links for a particular mechanism. So you should know for a particular mechanism how many links are there, that is denoted by suppose small n. Okay, and suppose the number of instantaneous center that you want to find out, that is denoted by capital N. So now then this particular relationship is there, that is number of instantaneous center n equal to n, that is capital N, that is number of instantaneous center, capital N equal to small n whole to the whole n minus small n minus 1 divided by 2. Okay, and there the capital N is the number of instantaneous center and small n is the number of link. That means from here, using this particular mechanism, can you tell me if we are discussing about the slider crank mechanism, how many instantaneous centers will be there for a slider crank mechanism? Who can tell me how to find out? Slider crank mechanism, how many links are there? We need to know about the links. That means because n equal to, that is number of instantaneous center equal to n whole into n minus 1. That is the number of links. This small n's are number of links divided by 2. So for a slider crank mechanism, how many links are there?
4 links.
Who can tell me? Okay, 4 links. So that means 4 whole into 4 minus 1, that is 3 divided by 2. Okay, that is how many instantaneous centers will be there? 6.
6.
Okay, that means if you are going to use this particular method, suppose for a slider crank mechanism, you have to do the analysis, velocity analysis, and using the instantaneous center method. Then initially you must know how many instantaneous centers are there. That means 6 are there. After that, your task will be to locate them properly, and after that, your rest is simple. You're going to use that particular knowledge. That means the for a particular point, if on a particular link, if you are talking about uh, finding out the velocity, then it is proportional to the distance of that particular point from that instantaneous center. Okay, so that concept later on you will use. That is as easy as that. So similar is the case if we are talking about a 4-bar mechanism. Definitely name itself suggests number of links 4. So similar is the case here also. 4 into 4 minus 1 whole by 2 it equal to 6 numbers will be there. Okay, and there will be suppose for different mechanisms we are going to see how to find out the instantaneous center. Okay, and will solve small problems with respect to it. Okay, up to this much I believe it is okay how to find out the number of instantaneous center. Later on we'll see how to locate them. Okay. So these things we are going to discuss later on. How to here it is about the locating, but prior to doing this particular thing, okay, how to locate for a slider crank mechanism, for a 4-bar mechanism, we must know what are the criterion for locating the instantaneous center. So that thing we are going to discuss now. Okay, so I believe up to this much it was clear. I hope so. Okay, now our task is we should know. Now we know that means how the instantaneous center concept can be utilized. Okay, we know that the instantaneous center, if you can locate properly, and then velocity, how it is related. So it is basically proportional to the distance from the instantaneous center. So those things we know. Next, we have also understood how to find out the number of instantaneous center. That means how many number of instantaneous centers will be there for a particular given mechanism. That thing also now you are able to find out. Now we should be able to find out the location. We should be able to locate it. That means I know, suppose who are the students now. Okay, suppose in 5th semester mechanical, first I know if the students are there, then suppose this way I can teach this particular subject. Next I know, suppose this many students are there in this particular subject. Next I should know who are the students, okay, or where they are located, that kind of thing. So now location of the instantaneous center. So there are certain apart from the Kennedy's rules and all, which we are going to discuss later on. So apart from that, there are certain observations have been already done. Some practices are already there, which suggests how to find out the location of the instantaneous center for certain standard cases. Now, so some of the very standard cases which we generally encounter in the different mechanisms with respect to right now whatever mechanisms we will be discussing, mostly the lower pair mechanisms, sometimes higher pair mechanism also. Okay, so in those cases, okay, we know that mostly we encounter the rotational motion, that is the pin joints, we encounter slider, we encounter having the translation motions and all. So for those cases, where is the location of the instantaneous center, we must know it. Okay, so now first case, for a pivoted or pin joint, okay, the instantaneous center of the two links, it lies on the center of the pin itself. So now look at this particular figure. Okay, so we have got link I1 and link 2. Okay, and they are joined by this pin joint. Okay, there is this particular pin joint. So for a pin joint, where is the location of the instantaneous center? It lies at the center of the pin itself. Okay, that means if this kind of cases is there, then we generally denote instantaneous center with I, not 1, sorry, I. Okay, and this is link 1, this is link 2. So this is the instantaneous center between link 1 and 2. So I suffix 1, 2. I denotes instantaneous center. Suffix 1 2 means it is the instantaneous center between 1 and 2. That is how we denote it. And where is the location? This is the location itself, at the center of the pin itself. Okay. Similarly, in case of a pure rolling contact of two links, okay, the instantaneous center lies at their point of contact, because the relative velocity between these two links at their point of contact is 0. So now this kind of case where it is, suppose this is link 1, we are considering this surface link 1, okay, this roller is link 2, okay, and it has got a pure rolling motion, and we have got the contact here. So the instantaneous center between this one link 1 and link 2, where it is lying at this point of contact. Okay, this is, that means I instantaneous center in between 1 and 2, I1 2. Okay, so that is how we can locate. If that kind of situation is there, directly you can locate here. Similarly, in case of sliding motion, the instantaneous center lies at infinity in a direction which is perpendicular to the path of motion of the slider. Okay, now that means if you look at this particular figure, so this is this surface, okay, fixed surface you can consider, or any other surface, and denoted by 1. Okay, and we have got the slider here, link 2, and this way it is having the, this is the line of stroke direction. Okay, now for this pair 1 and 2, okay, where will be the instantaneous center? So in this kind of cases for sliding pair, so instantaneous center will lie at infinity. So we are going to show it dotted line this way, okay, and it is the instantaneous center between 1 and 2, I1 2 at infinity. You can show it arrowhead, okay, the arrow will go on like this, okay, you cannot draw up to infinity, so it is up to infinity. Okay, and similarly for this kind of curve faces, okay, so this way if it is curved, then at the center of, suppose this is 1, this is 2, in this kind of situation, then it will lie at the center of this particular part, at the center of curvature of the curved surface. Similarly, if this is the case, link 1 and link 2, okay, so here also the instantaneous center lies at this center of this particular curvature. So these are some of the standard way. Okay, understood? That means for pin join, it lies at the pin itself. These things will be useful. Similarly, for pure rolling contact, it lies at the contact point itself. For sliding point contact, okay, so it is at infinity, and direction will be perpendicular to the line of stroke direction of the particular slider. Okay, so these are some of the standards that we are going to use. Understood? Let me know. Okay, thank you. Similarly, there are certain words like the types of instantaneous center, like we have got permanent and we have got fixed one, okay, and neither permanent nor fixed type. So this thing will be you will be able to understand while we will be solving the problems. Okay, so basically, fixed means like permanent means actually it is at a particular location. Okay, so similarly fixed means suppose it will be there, okay, suppose for it will be finding or undergoing a particular relationship, but it may, the position may vary. Similarly, neither permanent nor fixed, okay, that will be secondary kind of instantaneous center. Okay, now there is one theorem known as the very important theorem, Aaron-Hall Kennedy's theorem, also sometimes only known as the Kennedy's theorem for three centers. And this is very and a very important theorem, and this concept also we are going to utilize while solving the problems to find out the instantaneous center, and thereby finding out the, all those velocity, etc. Okay, so what does it state? Actually, it states that if three bodies, okay, they have got plane motion in between them, so their instantaneous center will lie on a straight line. Okay, so now if we have got three bodies, three different bodies, which this kind of situation you are going to encounter while solving the problems. Okay, while going through finding out the instantaneous center for different cases. So three bodies if we have, okay, suppose that means three bodies means in our case we will be considering three different links. Suppose link one, link two, link three, that kind of thing. And the concept is that if they have got plane motion in between them, then their instantaneous center will lie on a straight line. Okay, so suppose three bodies you have got, suppose one, two, three. Okay, three bodies we have got one, two, three, and suppose that means if we have got one, two, three, these are the three different links. Then in between one and two, we have got I one two, that is the instantaneous center between one and two. In between one and three, we'll get another instantaneous center, that is I one three. Similarly, if we consider two and three, we will get another instantaneous center that is in between 2 and 3, that is I 2 3. So by just normal observation for three bodies, it's easy. Okay, we can see that there are three different instantaneous center. And now as per this particular theorem, what does it state? This I12, I13, I23, they will lie on the same straight line. Okay, so it cannot be, suppose one is there, another, suppose I12 is here, I13 is here, I13, I23 will be here. So it cannot be. So what does it say? They will lie on the same straight line. Okay, suppose one two, I12, I13, I23, or like that. So that kind of situation will prevail. And this concept will be very useful while locating the instantaneous center. Okay, some of the instantaneous centers you will be able to find out, look or locate by observation by using, suppose, the concepts of pin joint, the slider, etc. And some others you'll be, for finding out them, you'll be using this Kennedy's theorem. Okay, and we have got a very small like you can say derivation for it, that is proof, not exactly derivation, proof for it. Okay, and you can just go through this. Okay, and you'll find that actually they should be there. Okay, so up to this much, let me know whether you have understood or not.
Understood. Understood, sir.
Okay. Thank you. Now we'll what we'll do, we'll check or we'll see how to locate the instantaneous center for different mechanisms. Okay, so first, suppose you have got this particular, this is what kind of mechanism is this particular figure?
Four bar mechanism.
Yes, correct, four bar mechanism. So suppose you have to find out the instantaneous center for it. Okay, how to find it? Suppose you have to utilize the instantaneous center method. Okay, and ultimately you are going to find out the velocity and all. Okay, so for that, what you should be able to do, first task will be to, you should be able to know how many instantaneous centers are there. So for that, you have already got that particular relationship, that is n equal to, n is the this n is the number of instantaneous center, it is equal to n whole into n minus 1 by 2. So this is four bar mechanism, mean how many links? Four links. Okay, n
Four.
equal to 4. 4 whole into 4 minus 1, that is 3, that is divided by 2. Okay, that is 6. So now it is known how many links are there, or how many instantaneous centers are there. 6. Okay, next task, you should you should know what are the who are there, that means. Okay, now you know how many are there. Now you should know who are there. So how many links? 1, 2, 3, and 4. Okay, so now in between 1 and 2 there will be I12 you will get. Okay, I am not writing the I. Okay, because writing in computer it becomes difficult. So I12, similarly in between link 1 and 3, I13, similarly you have got I14. Correct. Similarly, if you should say in between link 2 and 3, I23, link 2 and 4, I24, and anything else. 1 2, in between 1 and 2 it is 1 2, 1 3 1 4 2 3, then 2 4, and in between 3 and 4 it is I 3 4. Okay, so how many instantaneous center we have obtained? Okay, from this expression we have obtained there should be 6, and we have named the 6. Okay, that means only I want 2, in between 1 and 2, in between 1 and 3 I want 3, in between 1 and 4 I want 4. For 1 it is done. Similarly 2 3 I 2 3, then I 2 4. Okay, and I 3 4. Okay, so these are the 6 1 2 3 4 5 6 6 instantaneous center. That means naming also it is done. So this instantaneous, suppose I want to instantaneous center between 1 and 2, it is equivalent to I 2 1. That means it is also same thing. So you don't have to write like 1 2, then 2 1, or 1 3, or 3 1, or like that, or 3 4 after that again 4 3 and all. Okay, understood? So these are the 6 instantaneous centers. That means we know how many are there, who are there, that is also known, where are they, that is unknown. Up to this much it is understood.
Yes,
Okay,
sir.
so that means it's a 4-bar link. Okay, so from here we have obtained how many instantaneous centers will be there. It is 6. Next we have found out who are the instantaneous centers, that is I12, I13, I14, I23, I24, and I34. These are the 6. Now we must know where they are hiding, where they are located. Okay, as if we are playing hide and seek. We now know how many people are hiding. 6 people. Who are the people hiding? That is I12, I13, I14, etc. And now our task is to locate them, where they are hiding. Okay, so now for locating where they are hiding, we have got those different cheat codes. Okay, different cheat codes means, suppose we already know, suppose if it is, suppose pin join, where it is located, slider, where the nail it is there. We also have got, we are equipped with the Kennedy's theorem also, Kennedy's theorem of 3 centers. Okay, so these are the different knowledge that we are going to utilize. Now if you look at this particular figure, so this is whatever is the darker sides that you have got. Okay, this shows the 4-bar mechanism. Okay, and we have numbered the link 1 fixed link 2, this is link 3, and this one is link 4. Okay, so now right now we are just showing for a particular 4-bar mechanism how to locate it, and later on we can utilize this knowledge. And the same thing can be extended to any kind of 4-bar mechanism. If in a question it is given, suppose 4-bar mechanism, you have got a 4-bar mechanism, suppose link AB, suppose this much length. Okay, suppose BC is suppose of this much length, CD is suppose this much length, and all, and suppose they are making this angle between suppose A and B, or like that, whatever is given. So as per that, you should be able to draw the configuration diagram. This is nothing but the configuration diagram for any arbitrary 4-bar mechanism that has been shown here. But in your case, while solving the problems, you might have the different values, and as per the different values, you have to utilize the proper scale, and you should use the proper geometrical instruments to draw the configuration diagram. And rest, the method will be similar. Right now we are making a generalized method how to do it, and later on the thing will be to, you can just you can solve any kind of this kind of problem. Understood? Right now we are doing to the method for doing so. Up to this much, let me know.
Clear, sir.
Okay, thank you. So now that means now we have got this particular instant 4-bar mechanism. Suppose let's suppose we have drawn this as per scale, as per the whatever is the given criteria that has been given about this particular angle or the link length, etc. As per that, suppose we have drawn this configuration diagram. Next, from this case, we have obtained that 6 number of instantaneous centers are there. First step is over. Next, we have also found out who are they. These are the instantaneous centers. That means if I am able to locate this instantaneous center, my work is over. Okay, so now for that, what are the different knowledge that we can utilize? First thing is, we can utilize the knowledge about locating the instantaneous center for different cases, like the pin join, the sliders, etc. Similarly, there is another very important thing, that is the concept of Ehrenholz or can say the Kennedy's theorem that we also have. Okay, so for that, how we are going to do? Let's say. So now we have got this link one, link two, link three, link four. So link one and link two. We know in between them definitely there will be the instantaneous center. So what will be the instantaneous center name for link one and in between link one and two? It will be
Good.
I21 or I12. Okay,
I
same thing.
want to.
Okay, so I12 or I21. So now this link 1 and 2, you can from observation you can see that these are all what kind of joints are they? This join, this and this. What kind of joints? The different links 1, 2, 3, 4. They are joined by what kind of joint? These are the pin joint, right? By looking at the figure, we can say these are the pin joints that we have got. Correct?
Yes,
Okay.
sir.
Now, if two links are joined by pin joint, okay, where the instantaneous center lies? It lies
In the
at the yes center of the pin itself. Okay, that means one and two. This is the link one. This is link two. So I12 lies at the center of the pin itself. So this itself is I12. That is the point. Similarly, once it is this knowledge is there, so let's let's make it big. Okay, so this is one and two. Okay, so this is in between them. It is I12. Similar is the case. Very easily we can locate in between two and three. It will be I23. Okay, already it is there. Already it is written I23. Similarly, in between link three and link four, they are also joined by pin joint. So location of the incident center I34 will be here at the center of the pin itself. Okay, and similarly in between 4 and 1 it's also is a pin joint, so I14 will be here. Okay, up to this much very easily we have obtained. Yes, I think it should be very easy for all of you. So that means I12 is done, I14 is done, I34 is done, and I23 is done. So what are left? We have got I14 still hiding, I not 14, sorry. I13, it is still hiding. Not this, okay. It is already found out. Okay. And I24, it is also hiding. So other four we have located. Okay. Other four, they are already out of the link. So now for that, what we will do, we know that now I13 and 24, they're hiding. Okay. Understood? Let me know. Hello. Okay, thank you. Okay, so
understood.
for that, what we'll do, we are going to use the Kennedy's theorem. So Kennedy's theorem, what does it state? Okay, that means if we have got, what does it state? Okay, if three bodies have got plane motion, okay, their instantaneous center will lie on a straight line. Okay, so this concept now we are going to utilize for finding out the other two instantaneous center. So for using it, what is required? Okay, so right now here it is the same thing that we are discussing. Okay, what is the procedure? First, we have found out this particular number of link. Okay, 6 instantaneous centers. So then the different instantaneous centers. Okay, so in a tabular way. Okay, we are finding out that it's different links that we have got 1, 2, 3, 4, and the different instantaneous center. For link one, it is I12, 1, 3, 1, 4 like that. Okay, for 2, 2, 3, 2, 4, 3, 3, 4 like that. Okay, this 6 just now we have. Similarly, we have find out by inspection, 1, 2, and 1, 4 is kind of fixed. Okay, so 2, 3, 3, 4 kind of permanent. Why 1, 2, and 1, 4 are fixed? So see, 1, 2 and 1 4. Why they are known as the fixed instantaneous center? Because they are correlated with this particular fixed link. Okay, it cannot move. Okay, exactly, it will be the point. Why 2 3 and 3 4 are known as the permanent? Because we know that 2 3 and 2 4, okay, it will always lie at this center of the pin itself. But during the course of movement or course of work of this particular forward mechanism, the position of the links, it may be different. Okay, that means 2 3, suppose if the suppose the next link, okay, suppose this is always fixed, this link is fixed. Okay, suppose later on sometimes what may happen, so this kind of position also it may be there, it may assume this kind of position. Then also 2 3 will be here, it's a permanent, that means it will be there at the center of the pin itself, but location has been changed. But the other two, that is 1 2 and 1 4, it will be always here. So that's why they are fixed. And other two, neither fixed nor permanent. After this class, I believe it should be okay. Yes. Hello. Okay, thank you. Okay, so apart from this, apart from making this table, we can also do this by drawing a particular circle. Okay, this way you can draw the circles and 4 links are there. So on this particular circle, you can number these 4 different points. Okay, 1 2 3 4 corresponding to 4 links. Okay, and you can join them. Okay, that means I can join 1 4. Okay, so this similarly I can join this. Okay. Yes. So whatever the points that has been joined, so they are nothing but the different instantaneous center. That means 1 and 4 has been joined. So I14 will be 1. That means this one. Similarly 1 and 2. So I12 will be another 2 3. So I23 if I will be another. Similarly I34 or 43 is another. Okay. And if you make this dotted line, you can join 42 or 24, 42 or 24 and 1 3. Okay, or 3 1. Okay, so this is also the another way of doing. So while solving the problem, you can so do by it in any one of the method. Understood? Yes, up to this much I hope it should be clear. Let me know. Hello. Okay, okay, thank you. So up to this much it is done. So what is left? I13 it is hiding and 24 it is hiding. So if I want to locate I13, what is the thing that I know? Right now we are going to use the Kennedy's theorem. Okay. What is the thing that we already know? That means it is a instantaneous center between link 1 and link 3. That means link 1 and 3 always will be there. Now, what I can do for using the Kennedy's theorem, what is required? It is required to have 3 bodies, and these 3 bodies should have planar motion in between them, plane motion in between. So for doing so, what I will consume, we are going to find out I13, definitely 1 and 3 has to be considered. Apart from that, these are the 2 bodies. That means 1 and 3 will become 2 links. And apart from that, I require another link. That means 1 is done, 3 I have to consider done. Okay. Let's consider 1, 4, and 3. That means this way, right hand side. Okay. Let's consider 1, 4, and 3. Okay. These are the 3 bodies. And definitely they have got, they are joined by pin joint, so they have got relative motion in between, planar motion. So in that particular case, what we are going to do, we will find out the instantaneous centers. Okay, this suppose what is the instantaneous centers? That means if I consider 3 bodies, 1 4 and 3, 1 4 1 3 and 4 3, these will be the different instantaneous centers. Okay, so for this case, let me know who will tell me what are the. Right now we are going to find out I13 because it was not known. All of you follow me, okay? For doing so, we are going to utilize the Kennedy's theorem. Okay. For utilizing Kennedy's theorem, we have to have three bodies which should have planar motion. So if we are talking of finding out I1, 3, that is nothing but the instantaneous center between link 1 and 3. That means 1 and 3 link should always be considered. Okay, they will become two different bodies, 1 and 3. Apart from that, as we require three bodies for using the Kennedy's theorem, we are considering suppose this link 4. They are joined by this. Okay, and these three, 1, 4, and 3, they have got planar motion. Okay, 1, 4, and 3, these three bodies I am considering. So from here, what are the different instantaneous center if I consider 1, 4, and 3, these three bodies? Who will tell me? Anyone, please tell me. For 1, 4, and 3, this case, what are the different, how many instantaneous centers? So definitely 3 instantaneous centers. Okay, because 3 whole into 3 minus 2, that is 2, 3 into 2 divided by 2, that will give you 3 number of instantaneous centers between these three links. What are they? Who will tell me the names?
One four four one three.
1, 4, then
3 4
3, 4 or 4, 3, okay. 3, 3, 4, and and 1, 3.
one
Correct?
sir.
Okay, 3 1 or 1 3 same thing. Okay, similarly 4 1 1 4 same thing. Similarly 3 4 or 4 3 same thing. It is the instantaneous center between these two links. That okay. So that means these are the three instantaneous centers. And as per Kennedy's theorem, what does it state? These three instantaneous center will lie on the same line, same straight line. That is what is Kennedy's theorem. Okay. Now let's see what we can do. We need to find out 1 3. So 1 3 is still here, and for doing so we need 1 4 as well as we need 3 4. Now if you can see, so here already we have located 1 4. This is the I1 4 we already have here. Similarly we need to have I3 4. This is the I3 4, this point already located. Okay, that means I13 will lie on a line which joins this. Yes, that is what is the concept. So we are extending. You can extend both ways, no problem. But right now, as we already know, that will be here. So I am extending in this direction. Okay. Next, let's consider another thing. Okay. For doing finding out 1 3 only, let's now consider. I have to consider definitely 1. I definitely have to consider 3. Okay, in between I have to consider something else. That means 3 links will be required. Let's now consider link 2, which is also connecting 1 and 3, and they have got plane motion in between them. That is, I am considering now these three bodies, 1, 2, and 3. So for them, what are the different instantaneous centers? Who will tell me names? Tell me the names for these three bodies. If I consider these three bodies, what are the instantaneous centers? Who will tell me? Okay, I 1 2. Okay, I 2 3 and 1 3. Okay, correctly said. Okay, so these are the three instantaneous centers. Okay, now the good thing is I12 is already located. It is I12. This is the I12. Okay, it is already, we have already located I12. Done. I23. Okay, this is also another good news. We already have I23. This is this, and I13 is left. And where it will be? It will be on a line which joins. That means these three instantaneous center will be on the same line, and other two we have already found. So that last one, that is the remaining one, I13, will be also in a line which joins this. Okay, these two instantaneous center, and this way if I proceed, okay, now one logic says that it should be in this line, another logic says that it should be I13 should be along this line. So that means both the logic, when it will be satisfied, it will be satisfied for the point where both of them intersects. So I13 is located. Done? Understood how we have located I13? Let me know. Okay, thank you. That means
Yes,
now
sir.
I13 also is located. What is left? We are left with I24. Okay, so for finding out I34 also, it is the same thing that we are going to do. We are going to use the Kennedy's theorem. For utilizing Kennedy's theorem, how many bodies will require? How many links or bodies will require? Three. And they must
Three.
have relative motion between them. So if we are talking of I24, finding out I24, definitely for both the cases, you have to consider link 2 and 4. And in one case, you consider link 1. Okay, you can see they will be having 2, 4, and 1. They are connected and they will be having relative motion between them. Similarly, in another case, you can consider 2, 3, and 4 and use the same logic. And in one logic will say it will be along this line, another logic will say it will be along this line. Okay, and wherever both of them meet, okay, so this will be the point, okay, where both of them will meet, okay, and that will be I24. Same logic, Kennedy's theorem we are going to utilize, and that will be our job. Okay, understood? Let me know, have you understood or not, all of you? Let me know if you have understood or not. It's very easy once you know about these two cases, like for pin joint where it is located, similarly for sliding joints and all. Okay, sliding pair where it is located and all. Okay, and after that, if you can use the Kennedy's theorem properly, Kennedy's theorem states that three bodies, if they have got plane motion, then the three instantaneous center between them will lie on the same straight line. Okay, that is what is the concept, that is what is the law, and this particular concept we are going to utilize. Okay, so that is how we have found out the different instantaneous center for this kind of cases. So I hope all of you have, those who are attentive, those who are following me, all of you have understood the thing, right? Let me know. You can unmute yourself, you can let me know. I'll be happy then. Okay, now run say yes, thank you.
Yes, sir.
Okay, thank you. Subham also have understood. Okay, I hope others. Okay, thank you,
Yes,
Catherine
sir.
also. Okay, okay, okay. Seems those who are following me, all of you have understood. Okay, so this is how we can utilize the instantaneous center method for finding out the different velocities. So now the thing is, instantaneous center method we have utilized and we have found out the different instantaneous center. Later on, as per your requirement, if you need to, suppose our task was to find out the velocities and all, right? So after that, what we'll do, depending on the depending on your requirement, at least velocity of which point you want to have and all. Okay, depending on that, you have to find out. Suppose the that we'll be drawing these diagrams as per some scale only, right? The scale will be previously mentioned. Suppose during drawing the configuration diagram itself, we'll be having the proper scale, and the scale will be properly mentioned. And as per that, we'll be doing it. And later on, after that, if you find out measure the distances of the points from a particular instantaneous center, then that way you can have the conversion. Similarly, that relationship you can utilize and you can find out the different velocities of different points. And that is how we utilize the concept of instantaneous center for finding out velocities in mechanism. Okay. So with this, we'll stop here for today. And I hope all of you have understood the things. And in the next class, we'll be prior to going through acceleration analysis. Maybe we'll see how to find out how we can utilize the instantaneous center method for finding out the different instantaneous centers for slider crank mechanism, or maybe we can directly solve one problem where we can have the different numerical values, and this way directly the same thing can be extended for given numerical values. Okay, so with this we'll stop here for today. So thank you everyone for joining. We'll meet in the next class.
Thank you,
So
sir.
in the meantime,
Sir.
let me take the attendance. Yes, someone was asking some doubt. Okay, so as actually Buljit sir has mistakenly taken the first class, so I am entering the attendance during the first class itself. Okay, so respond to your name call. Samim, Hitesh sir, Hitesh sir, I can see.
Yes,
Biswajit,
sir.
Present, sir.
Catherine, I can see. Tapas, Jigyas,
Present, sir.
Subham,
Present, sir.
and Andreas, and Andreas. I think towards the very end he also joined. Okay, no. Asis,
Present, sir.
Khandeep, unfortunately, his father passed away. Actually, he informed me. Vishal,
Present, sir.
Samfang,
Present, sir.
Albaxina, Chodian,
Present.
Sendringdao,
Present, sir.
Aryo,
Present, sir.
Norangsi,
Present, sir.
and Jaideep.
Present, sir.
Okay, so thank you everyone for joining the class. Okay, we'll meet in the next class. Thank you.
Thank you, sir.